Hello everyone, this is Dr. Zia Tahir here. This video tutorial is about analysis of Castellated Beam as a shell in Abaqus 2020, and that is an example from chapter 11 of Thick and Thin Plates of Introduction to Finite Element Analysis using MATLAB and Abaqus, and that is from chapter 11. This one, chapter 11, thick and thin plates. Okay, and that is the detail of that three-dimensional shells, and here it is all detail of the problems. So the figure yellow show a castellated beam over a length of 12 meter. That is a beam. So that is a beam, and its length is 12 meter and is subjected to uniformly distributed load of 178 kilonewton and 6 from the both ends. There are 19 hexagons through the length spaced at 203 millimeter as shown in figure. So here in this figure, there are 19 hexagons and they are spaced like 203. The beam section is I as shown in figure blue. That is the beam section, and its overall width is 178 and its center to center overall depth is 596.2. So, and the thickness of web and flange is 7.8 millimeter and 12.8 millimeter respectively. And the material is steel with modulus of elasticity as 200 gigapascal and Poisson's ratio as 0.27. So here are steps. But before that, we need to select units, which units you are can be used. Set 1 is Newton meter Pascal and the set 2 is Newton millimeter megapascal or Newton per millimeter squared. So here, because most of the dimensions are in millimeters, so we will go for millimeter. Loads in Newton and modulus of elasticity is that is in gigapascal, so it will be 200,000 megapascal. Okay, so then the first step while you are going to use Abaqus, before that is a set work directory. So this is chapter 12 where I want to save everything. So I have just copied it link. So in Abaqus, file, set work directory, and that is the work directory. Okay. So now the work directory has been set. Then the first is create part and the shell extrusion. And that is the cross section which need to be first drawn, and it is being drawn like as a shell. So web and flange, they have different thickness, so they are actually drawn as shell. So here, uh, first I'll name it, name the model as chapter 10 beam, and I'm going to save it as file, save chapter 11. No, this is chapter 11 beam. Okay. So model is chapter 11 beam, and then its file CAE file is being saved as chapter 11 beam. So now I can create part by double clicking here in the model tree or here. So it is beam as shell and is a 3D deformable shell extrusion, and approximate size is a double of that what I am going to draw. So it is like 600. So I am going to do it as 1200. So that is, so now here I need to create that section, and overall width of flange is 178. So I'll use connected lines 0 and then somewhere there 178. Okay. Oh, it's not possible. So then 178 and 0 by putting its coordinates, and then I'll create rest of that. So that section has been sketched. So here I can add auto dimension to that by selecting all of this. So done. So it shows here like 178, half of that 89, 596.2. It's mean all that dimensions are correct. So select the entities to dimension. That is done. And now it says sketch the section for the shell for the extrusion. So that is done. Now it says that how much is the depth for extrusion, and the depth for extrusion is 12,000 millimeter. So it is 12,000 millimeter. Okay, so that beam has been now that is being sketched. But in this beam there are like hexagons, and these hexagons they have overall width of 406. If I simply uh, assume it as a circle, so it will be a circle of diameter 406 and radius of 203. So for this, I'll create a circle, and its circle center is 316 plus 203, 515 from this end or from this end. So I'll go there for that one. The next is you need to create cut in the part module and extrude cut. So here in the part module, that is create cut, and for that create cut there are different options. The first one is extrude cut, so I'll use that one. So extrude cut, it says select the plane for extrude cut. Okay, so that plane I have selected. Now it says that select the edge or axis that will appear vertical and on right, so that will appear on vertical and right, and this one will appear on vertical and left. So now that is the on this plane I need to sketch that. Okay, so now I'm using that left part. So draw that hexagon. I need to draw a circle from this left edge, which is 315 and 203. So which is 315 and 203. So here at this edge, the dimension is minus 6,000. So from that minus 6,000, and so from minus 6,519, so it will be minus 5,481, and so that is now the point. But I don't want that one. Okay, but later on I'll delete it. So now I'll create a circle on that point, and then the diameter of this circle must be 203. So it will be then, I'm going to enter value here 5278 and 0. Let's say, so that is now a circle is being drawn. Okay, so now to create that hexagon, I need to create another circle here, and then I need to create another circle there. So these are the three circles, and then now with these connected lines, create lines, connected lines, I'll connect their intersection points. Okay, now cancel procedure. So that hexagon has been created, and then I need to delete all unnecessary circles there, which I used to create that hexagon, and then this point as well. So now that is the hexagon being created. So just to check that if it is correct, created properly, I can add dimension from this point to right at the end of that. Okay, and it is 316. So that is what is required. The edge of that is at 316, and then I can add auto dimensions here. So done. So you can see that here that is 203, like whatever, and then so that is now created. So this one, a hexagon, is being created. Okay, so that is 3.16 from left edge and is 406. Now the next step is to create pattern. Here you'll have linear pattern. So there are two options here, linear and then radial pattern. I'll go for linear pattern. So it says select the entities for the pattern. So I'll select all that is done, and then that is direction 1 and then direction 2. That is direction 1. It's mean that here horizontal direction, direction 2 is the vertical direction. So I just want 1, and then in horizontal direction 19. Okay, so that is they are 19, and then center to center distance between one and the other one is its center is that radius of that, let's say circle. So 203 plus 203 plus 203, so it is going to be 609. So 19, and once you have entered it, so you can see that so it is being created there. Okay, so then you can delete dimensions. So here it says that dimensions, so you can select these dimensions and then done. Okay, so that's done, and sketch the section for extrude cut, it's done. Now it says that here, so end condition through all up to face, because it is required through all. Okay, sometime like as blind or sometime up to the face, but it's through all, and then you can change the extrude direction. Okay, but through all, so now you'll have that beam with 19 hexagons here. So that is in YZ plane. Okay, so this one you'll have now this one, like this beam is being sketched, and that is the create cut we have used here. Next is create material, and material is steel, and in megapascal its modulus of elasticity is 200,000. So here, okay, so for material here, select material, it is steel, and then elastic material elasticity, so that is 200,000 and then 0.3. Okay, so that material is being steel. So the next step is create section. So there are two sections need to be assigned for both sections need to be assigned for web and flange. So here is web. So shell homogeneous, continue, and then its thickness of web is 7.8. Okay, then create another section, and that is flange, shell homogeneous, and its thickness is 12.8. Okay, so now two section has been created. One is web with 7.8 thickness with one flange with 12.8. Next step is assign section to both web and flange. So here you can go here, assign section, and it says select the region to be assigned section. So this one, like web region, is being selected, and then section is web. Okay, done. So that web is selected. Now for the flange, so I need to select this top and bottom flange. So again here assign section. It says that select the region to be assigned section. So that one with shift, then with shift, so I'll select all those four, done, and then it is flange. Okay, so and done. So now section has been assigned. Next step is mesh, and there are three substeps: seed, mesh part, and assign element type. Okay, so here in the mesh module, uh, seed part and approximate global size, it says 600, so I am going to select it as around 40. So apply, okay, and then here OK to part mesh, and then it is being meshed. So now you can see on the top flange, it is, this one is being structured quadrilaterals, and then on the web, so they are free. Then here assign element type, so it is select the region to assign element type. So all that is being selected. Okay, so done. Now we have here element library standard, then it is geometric order is linear, and then family is shell. Now there are two options here. So because here are the quadrilaterals, so S4R, that is a 4-node doubly curved thin or thick shell. Because the thin plate, so we can use that quadratic, and S8R is that is a thick shell. So I am going for the linear, which is S4R. So that is now done. So next step is assembly, create instance. So here in assembly, create instance, and that is a beam shell. Okay, so instance has been created. Next step is create step, and here in the step, it is step 1, it is static load. Okay, initial journal and then static journal. Okay, leave everything as it is. So now then next step is create load. In the load module, create load. So here in the load module, that one is create load. Now the load here in this problem, that is as UDL, that is load per meter length. So this load need to be divided with the flange top surface width, so that this is being converted into pressure. So when it is being converted into pressure, so equivalent load as pressure on the top surface of the beam is 1 Newton per millimeter. So now that UDL is being converted into pressure. So here the load is now pressure, and then it is static load. Here is pressure, and then mechanical, continue. It's a select the surface for the load. So the surface for the load are here the top surface. Okay, so now that one and the other one, so that top surface is being selected. Okay, so done. Now it says that consider a side of shell or internal face brown and purple. So like lower side of it is brown, so I'll select purple, this one, and then the next one is magnitude. So magnitude of load is 1 Newton per millimeter, so it is 1, and that you have, so the load is being applied, UDL converted to the pressure load, and it is being applied there. So now the boundary condition, let's say left boundary condition, that is initial step, and it is fixed. So I'll use that in caster, continue, and now here on these edges, I need to apply boundary conditions. Done. And then here you'll have in caster all that fixed in 3D. So that one boundary condition has been created. So now I need to create boundary condition on other. Now the next boundary condition is right. On the right side, it is initial, mechanical, and then in caster, continue. So for that one, this edge I need to select. So I can rotate this one a bit. So here in this plane, I'll rotate it, and then I can see all the edges there. So this edge, so these edges has been selected and is done, and then in caster. Okay, so now those edges only, they has been selected for boundary condition for left and right. So now the first modeling part is done. As the modeling part is done, so then the next one is to create job in the job module, or here by double clicking here, or here in the job module. Okay, so create job. So I'm going to chapter 11 and beam. Okay, so without space, continue. Okay, and here the job has been created, and then submit it. It start running, and after some time it will be completed. Now the job has been completed. So here you can go results, and the last one is results and visualization of results for common plot options. So that is one here, or otherwise you can open it from the work directory. So you can open from work directory as well. Okay, so then results, here you got the results. So that is a deformed shape of this one, von Mises stresses. And then that is a vertical deflection, and you can apply here. So that is autocomplete. So you can go uniform and one times of that apply. Okay, and this one is both deformed and undeformed. So you can see that it is there is a significant amount of deformation there. Okay, so then you can create a report for those results. Okay, so I hope you like this video. Thank you very much for watching. So you can leave comment for feedback.